Welcome back to Facilities Design and Logistics course. In our previous lecture, we completed our discussion on the location models, and we are starting the facilities design part of the course, and this is in your book, chapter 2. We will consider, or we will discuss product, process and schedule design in this chapter, which may be considered as the first step for facilities design. So let's get started. The steps of the facilities planning process, whether it is a manufacturing facility or an assembly facility, we have covered this during the introduction chapter. We first start by defining the products. What products this facility will be producing or will be dealing with. Then, in order to produce these facilities, what type of processes and what activities do we need to accomplish? For example, what kind of manufacturing facilities or assembly operations we will perform, and who will perform these, and what kind of, for example, material handling activities do we need to do. So we need to specify all of these. Then we need to determine the interrelationships among the activities. For example, from one machine to another, how many parts, how many trips should I do? What's the flow between the machines? Or sometimes from one department to another, what is the flow? How many person, what kind of information, what kind of material is flowing. Then we need to determine the space requirements for the activities. Okay, so there is a machine, and for this machine I need this much space. There is a department that is responsible for doing this and that, and we need this much space, 100 meters squares, and etc. Determine the space requirements. Then, depending on this information, we generate some alternative facilities plans, the layout of the plan, where each department occurs. Okay. Then, with some objective, with some criteria, we evaluate these facilities plans. The objective that we evaluate can be the total distance to travel or the total cost. Okay, we evaluate them. For this alternative, what is the total cost? For the other, what is the total cost? And depending on this evaluation criteria, we select. Of course, this evaluation criteria may not be just a single criteria like cost. You can consider different criteria at the same time. Okay, we want a facility for which the customers are satisfied, for which has the least cost, which has the least time to produce, which has the maximum throughput rate. Many objectives can be considered at the same time. Then we will select the preferred facilities plan with respect to these criteria and then implement it. After implementation, we need to maintain that plan and adapt to the changes. If there is a change, if something is not going smoothly, you need to make changes and adapt it. And of course, after this implementation, we need to update the products and redefine the facility objectives and repeat these procedures if necessary, whenever necessary. So these are the steps of the facilities planning process. In order to generate alternative facility plans, we need to answer several questions. So what are these questions? What is to be produced? Okay, what we are going to produce? We need to answer this question. How these products are to be produced? Okay, what kind of machine? In what order? What are the processes that are necessary to produce? Is it an assembly operation? Is it a CNC or plastic injection molding operation? What kind of operations we need to produce, how these products are produced. And then another question, when are the products to be produced? What is the exact time of this production? Should I produce it now, or 1 week later, or 1 month later? How much of each product will be produced at each time? This week produce 20, next week produce 100. How much? I need to know this. I need to answer this question. For how long will the products be produced? Okay, so I introduce a new product to the market. Should I produce, or shall I produce it for 1 month only, for 1 year only, for 10 years? How long? There are, especially in technological items, they are changing very rapidly. But there are some items that have been produced for years. For example, construction materials, the steel that are used in constructions, they are being produced, the same product can be produced for years, okay? And where are the products to be produced? When we say this where question, it can be the location decision, okay? Where, in which city, in which country, or where exactly? Or you can consider this as in what kind of a production system. It is like a mass production system, or on which machine. So this where includes different aspects. And the answers to these questions are obtained from 3 different design items. The first one is the product design. And product design answers this question, what is to be produced? Okay, so what is to be produced is answered by product design. If I say this is 1 and this is 1. Then the next question, how are the products are to be produced? It is answered by process design. The next 3 questions, when, how, and for how long questions, are answered by schedule design. This last one, the 4th one, okay, it can be answered by location decisions that we covered in chapter 10, or it is also sometimes answered by the schedule design, on which machine, where this product to be processed. Okay, so in this chapter, we will be talking on the details of these product, process, and schedule designs. And what you should remember is product design answers what to be produced. Process design answers how these products are produced. And schedule design answers when, how much, and how long questions. Okay, so these product, process, and schedule design, actually they are necessary operations for a healthy manufacturing system. They are not only necessary for facilities design, they are necessary for making this production. But we will be approaching these product, process, and schedule design from the viewpoint of a facilities designer. Okay? So we will be gathering information from these 3 items as a facilities designer. We will get some information from product design, we will get some information from process design, and we will get some information from schedule design, and we will be using this information in facilities design. So from product design, we will be getting the information related to the specifications of the end product, its dimensions, the material that will be used in these products, the compositions of the materials or items in this product. These kind of information we will obtain from product design. From process design, we will be obtaining the information related how the product will be produced, the necessary machinery, So we will know the machines, the necessary machines and equipment, so that we can design our facility. And from the schedule design, we will be getting the information of the production plans, the capacity plans. These are obtained from the schedule design, especially, for example, in capacity planning. We will be identifying how many machines we need, and then we will be placing those machines in our facility. And also the material handling equipment, the storage requirements. We will be getting these details from the schedule design. So the schedule design specifies the production quantities and the schedules of the production equipment, and we will be getting all this information from the schedule design. So what is the relation of the PPS, product, process and schedule design, with the facilities design? Actually, in order to design your facility, we need to consider all of them together: product, process and schedule designs. And facilities design requires information from each one of them. Okay, facilities design, we can say it is in the core of these items. So let's get into the details of these three design items. The first one is the product design. As we said, in product design, we are answering the question of what we are producing. So by product design, we are determining which products to be produced. Again, look, as a facilities planner, this is not our task. We are not doing this product design. The product design is done by the top management. But we are collecting information. We are getting some necessary information from this product design to use in our facilities design. Okay. Usually, this is done by the top management, and it's based on market research and forecast information. The detailed design of a product, what to produce, okay, it's influenced by different items like aesthetics. So the customers should like it. It should be aesthetic. The function of the product should satisfy the customer needs. The materials that we are using for this product, they should be cheap, they should be durable, they should be strong at the same time. Okay. And also the manufacturing considerations. So the product should be easy to manufacture. We should design the product in such a way that manufacturing is easier and cheaper. The major design criteria in product design is the product must meet the needs of the customer. Okay, why do we produce this product? To satisfy the customer, to meet the needs of the customer. And for this purpose, there are different methods that can be employed. One of them is the quality function deployment. Simply we call it QFD. This is a method that is used to identify customer needs and translate these customer needs to product specifications, to product characteristics, to product design, to tolerance requirements. Okay, so as a customer, let's say you need a device to control your computer remotely. Okay, this is your need. Then what we do in QFD, we try to identify, okay, what exactly you need. You need to control your computer for what purpose? Okay, so you are a teacher, you are teaching in a classroom, and you want to just use this device for slide transition. Okay, what else will you use it? Okay, if there is also a pointer, so that while showing that slide during the presentation, I can point on to specific areas. It will be fine. Okay, this is another need. And what else? Okay, sometimes at some point I may need to just black out the screen and ask a question to the students, and then depending on their answers, open the screen and go to the new. Okay, this is another need. So now I am specifying your needs, and I need to translate it into an electronic device, so that a remote controller, so that it will be able to move or satisfy slide transition in PowerPoint, move between the slides, and then there will be an integrated pointer which will be working wirelessly or with Bluetooth technology, and then you will be able to black out the screen, stop the presentation, and etc. So we are transferring all those customer needs into these product characteristics by using QFD. Okay, we will not go into the details of QFD. It is a topic of another lecture, but it's a methodology used in product design. Also, we can use benchmarking. In benchmarking, what we do is we identify a competitor for our operations, and we just compare our operations or our product with those benchmarking or selected product or selected competitors' product. So we can use benchmarking to identify the best practices from the most successful organizations. So there is already one product in the market. Let's say you can compare your case or your product with that one by benchmarking. Okay. So in product design, what do? We, of course, everything starts with financial analysis in order to develop a new product or update a product. First, you need to do financial analysis. It is economically justifiable or not. And then you need to use QFD method or benchmarking to identify the product characteristics. Of course, financial analysis continues at each step. It is not just at the beginning. As you do QFD and satisfy or specify the product characteristics, again, you need to do this financial analysis to understand if it is economically justifiable. Then from there, you come up with your design details. Okay, so when you come up with your design details, you are using, or let me say not you are, the product designers use several design tools. These are used to specify the characteristics of the products. It can be pictorial representations or prototypes of the products. So as a facilities planner, you may get this information from the product designer and use them while designing the facility. Okay, the photographs of the product or the prototype of the product. As a facilities planner, if you don't know what you are going to produce, the size of the product, is it a smaller one? Is it a larger one? Is it producing, for example, the manufacturing facility, is it producing a very hot metal, or is it producing a plastic part? So you need to know this to come up with your facility design. You can use the exploded assembly drawings or detailed component part drawings. So I will be showing examples on these. So this is an exploded parts photography. You see, this is the part, and we call it as exploded parts because the final product is the assembly of these small components. So you are using these components, and each component has an ID number, has a name. It is recorded in your database, and when you assemble them, you will obtain your final product. So this is a so-called exploded parts photography. Again, this is the design of this product is not the task of facilities planner. The facilities planner get this after the product has been designed. We get this exploded parts photography to understand, okay, we are producing this item, and then uses this information in the facilities design. This is another example. it's an exploded assembly drawing, not photography, but drawing. In the previous part, this is the photography of the part. Okay, it's the actual photo. But this one is a drawing, computer drawing of the part. Again, as you can see, there are 11 different components. For each component, you have the part numbers, and you can see how they are assembled together to obtain your final product. This is another example of a product, again exploded drawing for a pipe valve, and you can see two different views, the front view and the top view of this, and all the necessary information related to the components are given here. This is another example of a component part drawing. This is not the final product, just the component of a product. And it's a very detailed drawing, as you can see. You can see all the dimensions, the tolerances of the drawings from two different views. So, as I told you, in product design, we answer, in product design phase, we answer the question what to produce. And as a facilities planner, we get some information resulting from the product design, and we will make use of that information in facilities design. Again, this product design is not the facilities designer's task. We just get information resulting from this design. Also, the second is the process design, and in process design we answer the question of how this product is produced. Okay, and the information on this, how this product be produced, is listed in several different types or charts or figures. So parts list, bills of materials, route sheet, operation process chart, and flow process charts. Okay, so these information or the process designs are finalized with these types of lists or charts. Also, in process design, we decide on who should do the processing, whether we are doing it inside our facility or we are buying it. So we need to make this decision, make or buy decision. What kind of equipment is necessary to do the process design? This is also answered during the process design phase, the equipments. And as a facilities designer, again, if we go back to that, we need all this information, so that if it is a make, then we need the necessary equipment. But if it is a buy, if we are buying this product from outside, we don't need the necessary machinery, so we don't need to allocate for that machinery. But we need to allocate the space to receive that product from the supplier and a space for storing that item. Okay, so it depends whether you are making the product by yourself or buying it. Again, depending on the type of the equipment, the size of the equipment, you should decide on the space requirements. So which equipment will be used for each product is necessary, a necessary information for the facilities planner. And how long it will take to perform the operation is also important for you as a facilities planner, and this is also answered during the process design phase. Okay, so we said that in process design, we are determining, identifying the required processes. What kind of processes we need to produce the products that are designed during the product design phase. We are also making this make or buy decisions, or we sometimes call it sourcing decisions. Are we outsourcing it or insourcing, producing inside or buying outside? And we can come up with just a simple, very simple make or buy decision process. So we can start asking questions. Can this item be purchased? If no, I mean there are no suppliers of this item, the answer is then the decision is to make it by yourself. If you cannot buy it, you will buy it. You will do it by yourself. But if there are some suppliers that are producing these parts, then you can ask this question: can we make this item by ourselves inside the facility? And if the answer to this question is no, it means that your only option is to buy. But if the answer is yes, so what does it mean? It means that there are suppliers outside, and also you can produce it by yourself. There are two options. Now what you should consider is, is it cheaper for us to make than buy? If it is no, if the answer is no, if it is cheaper to buy it, then you will buy it. Why to produce it yourself? But if it is cheaper, then you should also ask this question. You need some capital, you need some initial investment to satisfy or to start producing this item. Is that capital or capital that you have satisfactory to produce it? If the answer is no, of course, you will buy it still. If the answer is yes, then you will make it. So this is a very simple process to decide on whether to buy or make the product. Of course, when you are considering at this stage, when you are considering if it is cheaper to produce it or buy it, you need a very detailed financial analysis. It is not like a very simple answer, very simple question. Okay? You need a very detailed analysis at this stage. Of course, these managerial decisions requires input from finance, industrial engineering, marketing, process engineering, purchasing, human resources, from all these different departments of your firm or company. And at each step, you need to consider the information to give your make or buy decision. Okay, so after identifying these required processes, by the way, we said that can be listed in parts lists. These parts lists are tables like this one, which provides the information of the assembled components to come up with a final product. So the parts lists includes the part numbers, the part names, their make or buy decisions, the number of parts per product, and the drawing references. So let's have a look at this example parts list. You see, there are some information at the top. The company that produces this part. The product, you see the product information. It's an airflow regulator. This list is prepared by this person, and you can have a date for that. Then, in order to produce this airflow regulator, what types, what parts or components do you need? So you see the part number, the name of the part, which is a pipe plug. There is a drawing for this pipe in your database, and it's recorded with this drawing number. We need only one pipe plug to produce one airflow regulator. So this quantity gives you how many components of each you need. Then you know the material of this component, which is steel. You know the size of it, the dimensions 0.5 inches by 1 inches, and whether you are buying it or making it yourself. So you are buying it. So for this component, you don't need an equipment, you don't need a machinery. But what you need a space to store it. You need let's say a dock in your manufacturing facility to receive it from your suppliers. The second one, again, part number, part name, quantity, and as you can see, it's make. It means that you need an equipment, a machinery to produce this one, and this is the size of the product, and you need to allocate a certain space after and before producing this item for the raw material and for the final product. And for each component that are used to produce this product, we have all the details here. So you may be producing maybe 100 different parts. This is just one of them. So for each product that you are producing, you are preparing such parts lists. Another way to represent the products, the components of a product, is the use of a bill of materials. Bill of materials is also a parts list, but it is a structured parts list. Okay, it contains the same information as the parts list. So the part numbers, part name, make or buy decision, all this information is contained in bill of material. But at the same time, you can see the structure of the product. So when I say the structure of the product, you see in this bill of material table, again, it is a table which contains the same information here. Part number, part name, again the drawing number, quantity, make or buy decision. But there's another information here, as you can see, level 0, 1, 2, 3. What does these level means? Actually, the level, it is even clearer at this step. The final product is airflow regulator. And we call this final product to appear in level 0. Okay? In order to produce this final, airflow regulator, in the last stage of production, we are assembling the pipe plug to the main assembly. So we are using one pipe plug, assemble it to main assembly, and you come up with this product. And so we said that this is level 0. The components of this final product are assumed to be in one level deep in the bottom. So we call it level 1. In order to obtain main assembly, we need to assemble lock nut to the body assembly. So this main assembly is constituted of this lock nut and body assembly. Whereas pipe plug, there is no further assembly for that. We are just buying it, remember. Okay? So we are not further dividing it into further components. Okay, so then this is level 2. Then this body assembly, it is produced by assembling these two body and the plunger assembly. So these items are in level 3, and in order to have this plunger assembly, we are assembling all these components, and all of them are in level 4. So where do we obtain these parts? We are buying them. Or maybe we are producing them but not assembling them. So these operations here are the assembly operations. If you are producing, for example, this plunger by a milling machine or a turning machine in your facility, you don't have that operation. You don't see that operation here. This only shows the assembly operations. And whenever you assemble two or more components to obtain another product or another sub-assembly, you see that you are increasing or you are moving to another level. The final product is always at level 0. And in this table, this is the same bill of material. It is shown as a table, and in this table you can see the levels here. Level 0 is the final assembly, these 1, so you immediately understand that you are assembling these two to obtain one airflow regulator. Sometimes the quantity over here can be more. For example, let's say that this value is not 1 but it is 2. What does it mean? It means that you are assembling two pipe plugs with one main assembly because they are in level 1 to obtain level 0, this item. Okay, so for one airflow regulator, you need two pipe plugs. If that is the case, of course, the quantities that you see here will be different. Okay, so these are two examples of bill of materials, two different representations. Of course, if you are saving these bill of materials in your computers, it will be, better, or it will be the case that you need to save it in such tables. Saving it in such figures, of course, when you see as a user, when you see it, it is much more understandable for us, but not for the computer. For the computer, this is a better representation. Okay, so in process design, we also need to select the required processes to produce the parts or products. So we need to make decisions on how the products will be made. And how do we decide on these processes? Actually, if you are producing a new product, if you want to introduce a totally new product into the market, okay, which you haven't produced before, how can you identify the necessary processes? Of course, it is difficult, but the products are usually similar to each other in one sense. If you want to produce a remote controller, it consists of some plastic parts, some electronic parts, and etc. And you know that, okay, even if you haven't produced a remote controller before, from your experience, previous experience, you may say that, okay, in order to come up with this product, we need these kinds of processes. You identify the requirements. If you are producing a metal part, if you are producing, let's say, flat metal, then you will be using sheet metal as the raw material, and then you need cutting operation, you need stamping operation, you need bending and welding operation. So you may understand from the requirements, checking the material of the product, checking the final shape of the product, and then the available processes that you have. You can also identify or decide on these depending on your available equipment. There may be different ways to produce the same product, but if you have one machine already available, then you may decide to use that machine and that type of product. Also, it depends on the production rates. For example, if you will be producing in large quantities of a product, then you may decide to use highly automated machines together with industrial robots. But if you will produce only a few products per year, let's say, you just need a very conventional, not automated, manually operated machine. So you decide, depending on your production rates, you decide on what type of processes and what kind of machinery or equipment you need. And also future expectations affect your decisions. If you are expecting an increase in the demand so that your production rate will be increased, then you may, although it is not economically justifiable at this time, still you may want to buy an automated system or implement an automated system so that in the following years you can satisfy the demand. So it means that for different processes or for each operation, you can select different alternative processes. It depends on different factors. And again, let me repeat, we as facilities planners in this course, our task is not to do this process design. But if we know how these processes are designed and what kind of output they will be giving to us, we will make use of that information at the end. So we need to select the required processes, and this process selection procedures includes these steps. Okay, we need to define some elemental operations. If possible, we will identify some alternative processes for each operation. Then we will analyze these alternative processes and then standardize them, evaluate these alternative processes, and then select the best processes. So these are the steps of selecting the required processes. And the output of the process selection is given in the route sheet. Okay, route sheet is an important output of the process design. This is an example of a route sheet. Okay, so let's see. Again, at the top, we see some information related to the company, the product. This is the route sheet of a part that we are using in this product. Okay, this plunger housing. If you go to the bill of materials, the plunger housing is this one. It is one of the components that are used in airflow regulator, and if we go to this one, plunger housing, you see it's make. We are going to make it, right? And for that product, we have a route sheet so that we understand how we are producing this component now. We see its part number and etc. Now, in order to produce this part, we see that we need 1, 2, 3, 4 operations plus 1 assembly. So again, it's not important to understand what is it. But if you are someone working in this company, you would be knowing what these. So this is, as you can see, operation numbers is always a 4-digit number. It is 0104. This is first operation. And this operation number, as you can see, there is a description. It is the shape drill cutoff. It says it is performed on automatic screw machine, and the necessary cutting tools that are used in the screw machine are given here. The department that performs this also can be listed here. You can see the necessary setup time to start this operation. It is 5 hours. So after 5 hours of setup, you can start processing. And what is this setup time for? It is necessary to load the necessary tooling to this screw machine. And then the operation time to produce one component is 0.0057 hours. Okay, so you are doing 5 hours of setup time, then 0.0057 hours of processing, but it is only for one part. So if you want to process, let's say 1000 parts, what will be the total time? 5 hours is for the setup plus, okay, even if you produce one part, you are doing 5 hours of setup. If you are producing 1000 parts, still it's 5 hours. The setup time is the same. But this operation time depends on the number of parts. I mean, for one part, the operation time is this much. So if you are producing one part, the total time will be this. But if you are producing 1000 parts, then the total time will be 5 for setup plus 1000 multiplied by this for the processing of 1000 parts. And it means that it will be 10.7 hours if you produce 1000 parts. But if you produce one part, it will be 5.0057 hours, only one part. So this total time, you can understand or calculate it from the information in the route sheet. And also, we can see the materials of the parts or the parts used in this operation. Similarly, the other operations, their machines, their setup times, their operation times, all of them are listed in the route sheet. And the last one here, it is the enclosed sub-assembly. It's said that it's performed in this hydraulic press. There is no tooling and no need to use, a special tool here. And the setup time and the operation time are also given here. So as I said, this is one of the important outputs of the process design. Okay, so we will continue our discussion on process design and different charts that we are using as an output of the process design in our next lecture.